Once again, very good day to everybody. This is Computer Communication Networks, and in today's session, we'll discuss about an overview to the data link control DLC and MAC Media Access Control. So here we would be discussing about Ethernet 802.3 standard. Okay. So this is especially for you, my dear students and young researchers, and you can reach me at dr.christoananth@gmail.com. So before beginning the session, let me thank God for giving me this golden opportunity to deliver this useful session to share my knowledge among my fellow national, international participants, students and young researchers. So in today's session, we'll have a short introduction to DLC, data link layer. Then we discuss about physical network and logical network. Then we discuss about DLL services, data link layer services. We discuss about NIC, network interface card. Then about the sublayers of data link. Then we discuss about MAC, media access control 802.3 standard, about the MAC mechanisms, about the MAC methods, and MAC for shared as well as non-shared media, that also we will discuss. Then we will discuss the problem of data collision, full duplex as well as half duplex, then about the Ethernet at the data link layer, then layer protocol for the LANs, and finally we end this class with the independent work. I will give them in the Google Classroom. Please go through, please complete them. As you have experience already with me, I will be giving you BISH independent work and with the open-ended project work. Okay, right? So I'll also giving you some short videos to discuss the knowledge in our topics. So this is the data link layer. So naturally we will be exchanging information for over a common media. Okay. So generally we will have two services. One thing, it is going to allow the upper layer to access the media using a concept called as framing. So frame by frame it is going to access the media, and it is going to control how the data is being placed onto the media, how it is actually received from the media. So we are going to put it and retrieve it back. And for placing as well as retrieving, we are going to use a concept called as media access control as well as error detection. So generally you will use this data link layer for the exchange of frames between the nodes. You can exchange the frames over the common media of the physical network. So here media is not that media, multimedia I am talking about. Okay, so media is nothing but the medium that you are going to use it for putting the frames as well as taking the frames.
What is frame?
Frame is nothing but the time limit for transfer. So it's actually, media is nothing but a physical copper cable or maybe an optical fiber or maybe a medium through which, or maybe a tube, or maybe some physical mechanism through which the signals travel. So media here doesn't refer to audio or maybe animation or maybe television or maybe video and multimedia features. So this is the physical as well as logical network. Physical network, definitely it is different from the logical network. Logical network, we are going to define it by the network layer. We'll have a certain arrangement, okay, a hierarchical step-by-step addressing scheme as well. But physical network, physically interconnected. The devices are physically interconnected on a common shared media. Okay. So physical network is also called as the network segment. So this is the image or maybe a diagram where you have the data link layer protocols that is going to format the frame on a different media, and different protocols can be used for different media as well. So this is the data link layer. For every step or maybe for every hop along the path, the intermediary device is going to accept the frame from one medium, and it is going to decapsulate the frame and then forward the packet. So it is going to take the frame and it is going to forward the packet in the new frame. Data link layer protocol will have for every frame that is particular description. So that is nothing but the key element for the data link layer protocol. So control information for this data link layer protocol will be giving the information about what are the nodes are communicated with each other. And when communication happens, when it will start and when it will end. So that information it will be giving. And for example, if there is any delay, if there is any error, problem that is occurring, that also will be sharing. And which nodes will communicate next. For example, two nodes are communicating, when it will start, when it will end. And after communication, next communication starts, when it will start, when it will end. So these are the services. So whenever a communication happens, like we have a three network layer: header, data, trailer. Start, data, end. Header, packet, or maybe data, and end. So that entire thing you call it as a frame. Okay. So from the network layer and the physical layer, we have the communication. So three network layer and physical layer, we have a communication. And the data link layer is going to prepare the packet for transfer. Okay. So with a header and a trailer to create the entire frame. Okay. So we have the data, okay, nothing but the packet from the network layer, okay, and the header will be having this control information, like maybe addressing scheme, hierarchical addressing scheme located at the protocol data unit. And trailer, it is going to contain this control information added to the end of the protocol data unit. So this is the start and this is the end. So we have some field types as well. We have the start, stop, nothing but start of the frame and then end of the frame. And then you have naming or maybe addressing fields. You have the type field, okay, which is contained in the frame. Then quality control fields, okay, to check the QoS service. And then you have the data field, nothing but the payload, okay. So how much execution time, how much time it will take to run, how much time it will take to execute, what is the entire space that it consumes. Okay, so this is the fields for the error detection as well, to mark the end of the frame. Okay, for example, entire communication is done, okay, which means communication stop. Okay, so maybe if there are some errors that are there, we have the error detection mechanisms. Then you have the Ethernet NIC card, network interface card. So that is going to insert the system bus of the computer, and it is going to make the connection between the software processes that are running on the entire system. Okay, so you have the header, packet, data, trailer. So here within that, as I told you earlier, we have addressing schemes, we have type, you have quality control. Okay, so you have the frame start, you have the frame stop. Okay, within that you have the error detection as well. So a specific bit pattern, generally it will have the start of the frame 1 0 1 0, and similarly another pattern you have 0 1 0 0, it is the end of the frame. Within that you will be having the data and you will have the error detection schemes as well. So the network interface card is not all alone, okay, but there is some software process that are associated with the network interface card. So there we will be performing some intermediary actions for the safe transfer of the data. Okay. So this is connecting the upper layer services to the media. So data link layer, it is going to link the software and the hardware layers. As I told you in the normally if you had studied about internet programming, okay, or maybe networks, you would have gone through these layers: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, application layer. You have to start from below. Okay, this is implemented in the software, and this one, data link layer, physical layer, it is implemented in the hardware, higher level protocol layers. Okay, data link layer is going to link the software and hardware layers. And there are physical devices as well, as you see in the diagram. Okay, network interface card. So the physical devices are devoted to the data link layer, have both this hardware as well as software components. In the first slide even I told you, we have the upper sublayer and lower sublayer. Upper sublayer, if you can see, okay, software process. Down sublayer you have the hardware process. Okay, so upper sublayer defines the software process that provides the services to the network layer protocols. Lower sublayers, we have the MAC, media access process, provided by the hardware. Okay, So we have like several LAN technologies, Ethernet as well, and we have LAN sublayers also. One is Logic Link Control 802.2 and another one is Media Access Control 802.3. Actually, today's class is all about Media Access Control 802.3. So in the logic layer that we are expressing in terms of the standard 802.2. So you have this network layering protocol, we have the encapsulation process. So you have the header, okay. So LLC header, a logical link layer header, will tell the DLL, data link layer, what to do when the frame has been received. Okay. And logic link control, it is going to place the information of the frame in which the network layer protocol is used. Here you have two standards, one is internet protocol IP and then IPX standard. So this is the protocol data unit format. Okay, so you have DSAP, SSAP, control, information as well. So you have several bits that are associated, 8 bits, 8 bits. Here the length is actually 8 or maybe 16 bits. And then information you are having variable. And then similarly, media access control, we have how the packets are being placed in the media. Okay, so you have this 802.3 standard FCFS, first come first serve basis. Okay, so just like if you can see, okay, enter the class, whenever you come, you occupy the first seat. Second seat, third seat. It's a first come first serve basis, so you call it as the contention or maybe competition. For example, if in a competition you are coming first, you will naturally get the first seat. Second one, second seat. Last one will get the last seat. So it is competition or maybe contention. You are fighting it. Okay. So everyone shares the same bandwidth, but of course you have a slots. Okay. So media access control provides a data link layer addressing, and it's going to delimit the data according to the physical signal requirements. Okay. So you have the OSI model IEEE, data link layer 802.2 logic link control, and then you have 802.3 MAC. You have carrier sense multiple access and collision detection. This is CSMA CD, carrier sense multiple access collision detection. Okay. And in the physical layer, you have 802.3 10 base 5 coax cable, 802.3A, 3B, 3E, 3I. Which one? Different standards. This one thick coax, this one thin coax, this one broadband. Okay, this one stack LAN, this is twisted pair cable. So different cables are being used for the physical layer. Okay, so medium access control layer will be having this DLL for the physical signaling of the media. So data link sublayers, we will have this 3 network layer as we discussed earlier, header, trailer, within that data or maybe packet. Then you have 2 data link layer, one is LLC, logic link control, and another one is media access control MAC. In logic link control, you will have the frames with the network layer packet, and then network layer packet it is going to frame, and it is going to identify the network layer protocol. And in media access control, as I told you, contention or maybe competition. So it is going to address the frame and it is going to mark the beginning as well as end of the frame. Okay, so this is the data that is being passed. 1010, it is the start. Maybe at the end, maybe you'll have like 0100. Data packets. Okay, so 1 means up, 0 means down. So that like the cycle goes. And the 3 network layer and the physical layer is being interconnected. You're going to place the data frames, as I told you, placing data frames, identifying communication, what you call to be the media access control. So media access control techniques, it is going to define how the nodes is going to share the common access media. Okay, so there are different ways to place the frames. So the protocols for the data link layer is going to define the rules and regulations how you are going to place the frames. Okay, so maybe you can use highly controlled processes as well to place it. Okay, so that you can place the frames very safely without any interruption, without with too much security and privacy features. So the basic media access control methods. So you have sophisticated protocols as well dedicated for placing these frames. For this, we will have common shared media and non-shared media as well. So for the media sharing, how the nodes will share the media, and then you will have the topology, a structure, how you can establish the connection, okay, to be placed in the data link layer. Okay, so at one time there may be number of devices attempting to send and receive data. For example, you cannot say only at one time only one can send. Everybody can send because it is contention, it is competition. Everybody has the right to share. Okay, so there are two basic media access control methods for shared media. One is control and another one is contention based competition. Okay, control means every node has its own time. For example, I am dedicating one particular time for you. You can do it maybe within 10 o'clock to 10:05. Maybe 10:05 to 10:10 maybe you will be doing. 10:10 to 10:15 you will be doing. So control, everything is being controlled. Contention based means all nodes compete. So the strongest survive, the weakest fail. Okay. So this is the media access control method. No control. Okay, this is the shared media where frames are being exchanged. Okay, so there is no control, which means that no control means collisions will occur. Everybody will fight. Okay, so the here in the second case there are methods 1, 2, 3. So it goes like this. Okay, over the shared media. Take turns. 1 goes, 2 and 3 should stop. 2 goes, next should stop. Then 3. Okay. So methods which enforce higher degree of control prevents collisions, but the process has higher overhead, which means that when the process goes again and again continuously, this projector is running means of course it has some overhead. Every time it runs. Generator is running. It has some overhead. So methods that enforce a lower degree of control has lower overhead, but there are more frequent collisions as well. So this is the media access control protocol for the shared media. So whenever you are using this control access method, network devices, as I told you, it takes turns in sequence to access the media, but definitely you cannot say collisions does not occur. It occurs, okay, for a short period of time. So if the device does not need to access the medium, so the opportunity to use the medium passes the next device. So next device can go in the line. So media access control for the shared media. I have a packet to send, but it is not my turn. I shall wait. Okay, I have nothing to send. My turn to send. I will send now. So after sending this one occurs, and this one maybe if it has data packet, it can send. Okay. So everything after one after the another. This is what you call it to be. No. It is controlled access. Controlled access means one at a time. So control access, only one station transmits at a time. Devices wishing to transmit must wait their turn. No collisions because they are waiting. Okay. Some deterministic network uses token passing method. Okay. An example, token ring, FTDA method, and so on. Fully duplex connections. Contention based for the shared media. It is also called as a non-deterministic method. So contention based methods will be allowing any device to access the medium when it has data to send. Okay. So for this one, in order to prevent the confusion, you can use CSMA, carrier sense multiple access method. For the collision detection, you can say CSMA/CD, collision detection. So it will first detect if the media is carrying the signal. So if this carrier signal is being detected, which means that another device is transmitting. Okay, somebody is sending the data, and when the device attempting to transmit sees if the media is busy, it will wait and try again for a short time period. For example, if no carrier signal is detected, which means the device transmits the data. If the classroom is free, I will come and take the class. If the classroom is full, then I will go. I will maybe wait. Okay. So Ethernet and wireless networks use the contention based, competition based media access control. So this is the data collision. So maybe if the CSMA process will fail and two devices will transmit at the same time, you call it to be the data collision. CSMA process, carrier sense multiple access process, if it will fail and maybe two devices it will transmit at the same time, then what you call it to be the data collision. Okay. So if this occurs, data sent by both devices will be corrupted and maybe again you have to resend it. Again you have to resend it not at the same time but one after the another. So contention based media access control methods does not have the overhead of control access methods. So you can have recovery mechanisms to correct errors maybe if collision occurs. Okay, so media access control method for the shared media, contention based access. I try to send when I am ready. I try to send when I am ready. I try to send when I am ready. When I am ready, we'll send. Okay, so this is contention based. So everybody tries at the same time. Okay, so that is the way stations can transmit at any time. When I am ready, I am speaking. When you are ready, you are speaking. We will fight. Who is the best? Okay, so collisions exist. When you are ready, you are doing. Okay, so mechanisms exist to resolve contention. There is carrier sense multiple access collision detection for Ethernet networks and carrier sense multiple access collision avoidance for 802.11 wireless networks. So you have Ethernet as well as wireless networks for this shared media.
It's like VLAN, right?
Huh?
VLAN.
WLAN?
VLAN.
Via LAN, yes. So in the CSMA CD procedure, the device is going to monitor the media for the presence of the signal. If the signals are absent which means media is free, device can transmit data. If the signals are detected which means you can understand that another device is transmitting at the same time, which means that when another device is transmitting, all the devices should keep quiet, should wait until it ends the transmission. So traditional forms of Ethernet will use this method. So we already discussed about detection procedure. Now we discuss about avoidance procedure. CSMA CA, collision avoidance. So here device examines the media for the presence of the data signal. Media is free means device will send a notification across the media that it wants to use it. It wishes to use it. Okay. So device then sends the data, asking permission whether I can enter the class. Okay, you can enter the class means okay, then it will sending the data. This method is used by 802.11 wireless networking technologies. Okay. And for the non-shared media, it requires little or maybe no control before placing frames onto the media. So they have some simple rules and procedures for this one. Maybe for point-to-point topologies, you will use this CSMA CA procedures for non-shared media. So in point-to-point topologies, media is going to interconnect between two nodes, and in this case, nodes does not have to share the media with other hosts. Okay, and data link layer protocol has little to do for the controlling non-shared media. So we have two types. One is full duplex and half duplex. Full duplex means both devices can transmit at the same time and maybe receive at the same time. Okay. So on the same media, it can transmit and it can receive data. And data link layer assumes that media is available for transmission for both nodes. So both nodes transmit and receive on the same media. So there is no media arbitration necessary in the data link layer. So half duplex means devices cannot transmit and receive simultaneously on the same media. Okay. But duplex means it can. Full duplex means it can transmit and receive at the same time. Half duplex means it cannot receive and transmit at the same time. So Ethernet has established arbitration rules for resolving the conflicts arising from the instances when more than one station attempts to transmit at the same time. So this is the diagram for the non-shared media. we can send and receive, but not at the same time. We can send and receive, not at the same time. So this is the half duplex communication. Okay. So you have to wait until the frame is received before sending this one. Okay. So you have to wait and then you have to send them. So Ethernet at the data link layer is responsible for the Ethernet addressing. Okay, so what you call it MAC addressing, and it uses the MAC address. Okay, for this NIC. So for the space that address it is consuming, it is 48-bit address written in the hexadecimal format. So here you have IGGL layer. Okay, we have the organization OUI, organizationally unique identifier assigned by the IEEE standard, and then there is vendor. Okay, this is 24-bit. This is also 24-bit. So for the 24-bit, or maybe you can say for 8 divide by 8. So now normally you can say 3 bytes. Huh? No, 8 bit is equal to 1 byte. So 24 bits is equal to 3 bytes. Okay. So 3 bytes, 3 bytes. So organization assigns a globally administered address 24 bits or maybe 3 bytes. That is unique, that is peculiar for each adapter it is going to use. So here you have the Ethernet protocol. These are the common data link layer protocol for the LANs. You have preamble. Preamble means start. Preamble means start. Then you have destination, source, type, data, and then FCS, frame check sequence. So this is 8 bytes, not bits. 8 bytes, 6 bytes, 6 bytes. Source 6 bytes, type is 2 bytes, data 46 to 1500 bytes, which means 1500 multiplied by 8. Okay. Data. Frame check sequence 4 bytes, 32 bits. Okay. Preamble means start. It is used for synchronization and it contains a delimiter to mark the end of the start and end of the timing information. Destination address means it is the 48-bit MAC address for the destination node. So it's actually 6 bytes, 48-bit. Okay. Source address, once again, 6 bytes or 48-bit MAC address for the source node, source address. This is destination node, destination address. Type means it is going to identify the type that the upper layer protocol will receive the data after the entire Ethernet process is being completed. And then data or maybe payload. Okay. So this is the protocol data unit. You will have IPv4 standard, IPv6 standard. So not naturally this data comes under this IPv4 packet that is being transmitted over the media, and frame check sequence it is going to check. It is going to check if there is any frame that is being damaged, if any frame has any error. Okay. So this is the element work, STS switching, TST switching, and number 4 ESS toll switch. Go through this one. Okay, you should understand the basics of this one. Digital cross connect systems as well. I will be sharing them in the Google Classroom. Please submit them. As I am telling you again and again, 5 independent works, 1 open-ended project work. Please complete them at the beginning itself.